Very good. So it is time. Again, welcome everyone. I'm Fred Marcil. I'm the CEO and founder of Kube Innovation, who is producing the Innobyte, a bite force measuring device. Now, today I'd like to start by thanking everyone for joining us from all around the globe. We're going to have a great webinar by Dr. Costa Nicolopoulous on implant planning using bite force. I do want to stress that Dr. Costa agreed to present on bite force, and he is not being paid for this presentation, nor he does not have any conflict of interest. So today, implant is going to be the topic, planning and bite force, which we believe is a critical component of the planning to prevent complications and potentially catastrophic failures. Today, the format of the webinar is going to be a presentation from Dr. Costa. Then we also ask everyone, if you have any questions, please, you can write them in the Q&A section, or you can write them in the chat. Towards the end of the presentations, we will be happy to answer each and every questions live with Dr. Costa and myself. Everybody can expect as well a CE certificate by email in the coming days for attending this 1-hour course. And we're going to also make the recording available on YouTube for some people that missed the webinar or couldn't watch all of it. Without further ado, I'm happy to pass over the microphone to Dr. Costa, who has been a user for quite some time now, and is going to be presenting today on bite force. Dr. Costa.
Thank you, Fred. Greetings, everybody, from sunny Greece. And thank you again, Fred, for asking me to speak on this great innovation, which is certainly helping us in our implant planning and is also helping us to avoid disasters. I'm going to be sharing some disasters with you, and the only regret I have is not having had the Innobyte bite force measuring device before I started treating some of these cases that I'll be showing you. So the importance of this bite force measurement is it helps us reduce complications when treating implant cases. It helps us identify high-risk cases and helps us take the element of surprise out of these cases. It has certainly made a big difference to my treatment planning. It is a relatively new innovation. It's been around for a few years, if I'm correct, about a decade or a bit less. And for those interested, the recent relevant publications can be found by using this link. What exactly is this device? There is a display that tells us the bite force, and then there's a mouthpiece that gets covered with a single-use sleeve. The patient bites on it with both his front and his back teeth, and it gives us a measurement. Very simple. Takes a few minutes. So this is the protocol. Of course, with the single-use bite sleeve over this mouthpiece, there is an anterior guide and 2 posterior guides, 1 for each side. So it measures the full arch bite force bilaterally, and it displays it on the screen and tells us whether the patient has an excessive bite force, which is in the blue region, which is like 1,000+ newtons, like the case we are seeing on our right. You can see this patient has heavy bites, a grinder bruxer. So this tells us that this patient needs stronger or the strongest materials when restoring his bite. This is not an all-on-4 case. This needs more dental implants, especially if we're using materials, current materials like zirconia. We need more implants to decrease the pontic spans. We need to avoid cantilevers. We're definitely going to give this patient a night guard. At the other end of the spectrum, when we have a patient with dentures, like this patient on the bottom right, whose maximum bite force is 74 newtons, we tell the patient, you are a dental cripple. Your bite force is significantly reduced, and your function is significantly compromised, and we're going to motivate the patient to get treated with implants in order to restore their stomatognathing function to normal values between, let's say, 500 and just under 1,000 newtons. So look at this patient here. This patient is a patient that has full upper and lower dentures. They're the dentures, normal full upper and lower dentures without implants initially. And when we measure the bite force here, have a look at this. We're going to measure the bite force. And 61 newtons, that's very little. 61 newtons. Now the patient has some implants and has an implant-supported overdenture on something like locators or locators. These are the locators being placed. And now the patient is going to bite with the overdentures and look at the new reading. 540. 540 newtons. So what we've done is we've converted this dental triple with dentures with a bite force of 61 newtons to a bite force of 500 plus newtons with removable implant-supported overdentures. This is not one of my cases. We normally treat our patients with fixed implant prostheses, not with removable. But the take-home message is look at the difference in the bite force. And the question is, can you eat what you want? We ask the patient. Soft bread needs 25 newtons, whereas on the other end of the spectrum, steak needs close to 800 newtons. So here we've got soft white bread, 25, cheese, 90 newtons, a walnut needs 190 newtons, a carrot, a raw carrot needs 450 newtons, and a good steak needs 800 newtons, 700 or 800. So your quality of life is affected by your bite force. And that is a nice explanation to the patient why they need to have their bite force measured. So this is a nice chart to show patients. And of course, you can get all this information and all these charts from Fred, from Innobyte, from Kube Innovation. You can get all this information. So you can tell the patient, look, you are only biting, let's say 90 Newton centimeter with your dentures, and you actually need 780 to bite a proper steak. So look at this clinical case. This is a lady with only some anterior teeth, which are slightly mobile, and they need to be extracted. The maximum bite force is 74 Newton, and with normal dentures, removable dentures, without implants, it increased to 179, and then with all on four fixed prosthesis, she went up to 628, and that's remarkable. So the clinical applications range from a single restoration to convince a patient that they need a single molar replaced, or they need a crown instead of a a normal filling because they have high bite force that may fracture a heavily restored tooth with a filling. Full arch cases, either to motivate the patient to have implants or to tell us as clinicians that this is a high risk case, we need more implants and we need stronger restorative materials. So we design our cases to reduce failures by measuring bite force. Neuromodulators, very important. A lot of our cases, more than we believe, need neuromodulators. They need things like Botox. And we shouldn't just be randomly giving patients Botox. We should be first measuring their bite forces, and we should be treating them with Botox when we know that their bite forces are excessive. And also, we shouldn't just randomly be repeating. We should be repeating when we see that their bite forces are increasing again. Of course, appliance therapy is important, and we should be measuring the bite forces before and after appliance therapy, as well as TMJ disorders. So what do practitioners say around the world? This colleague, Dr. Bobby Stanley, says that she uses the Innobyte to motivate patients to have the proper restoration for a single tooth, either to replace a single molar or to restore a single molar the appropriate way. This is a friend of mine, Ramsey Amin from California, and he uses the Innobyte to reduce risk, especially with immediate loading cases, full arch cases. He's a full arch guy, and he uses this device to decrease risk, or to at least tell the patient that you are at high risk, and therefore we need to do A, B, and C. We need to add more implants, we need to use Botox, we need to use a night guard, etc. Also, there's a good study that came out quite a while ago from India that helps us decide what is the minimum size of the implant required for a patient's specific range of force. This was a combination of finite element analysis and percentage of the bite force on a specific tooth. So if you're restoring a single tooth, you should know what size, diameter, and length implant would be the optimum. So we said clinical applications are most important is to prevent failures, to prevent fractures of the material. Another colleague, this one from Canada, Dr. Behruz, she feels that with Innobyte bite force measuring, she's more comfortable with the choice of her materials and the prosthetic design, because we all know that there are risks with hardware complications, implant failures, ceramic chipping, occlusal chipping, screw loosening, abutment and screw loosening, etc., etc. This is one of my cases. If you see this case here, the first and the third quadrants, as well as the anterior, were treated with porcelain fused to metal, because that's what we had in the old days. This is a very old case. And then recently, I treated this patient with zirconia-supported prosthesis, a zirconia implant-supported prosthesis in the second quadrant. But what I failed to do is to measure the bite force. Had I measured the bite force, I would have designed it, or my restorative prosthodontist would have designed it differently. Or maybe I would have added an extra implant, or maybe a pterygoid implant to avoid that distal cantilever. So we have the teeth in the upper left posterior sextant that need to be extracted. I placed 2 implants, and 3 months later, this is what happened. We then measured the bite force and found that this patient has extremely high bite forces. So we should have designed it differently. First of all, zirconia may not have been the ideal material, although we love zirconia. We should have designed it differently if we needed zirconia. We should make the distal cantilever smaller, add a pterygoid implant at the back here. Anyway, the patient wasn't happy to proceed with additional implants, so the prosthesis was redone at our expense. Why? Because we didn't measure his bite force. If we had measured the bite force, we would have said to the patient, you're gonna break this. Then there's no excuse afterwards. If you do the bite force measurement before, it's an explanation. You explain to the patient that you are a higher risk patient. You need Botox. You need a bite plate. We're not going to place a cantilever unless we agree that we're going to place an additional implant at the back. If the thing breaks and you do the bite force afterwards and you explain, then it becomes almost an excuse to the patient. Anyway, we redid this prosthesis. This is the redo case. And look what we did. We made, instead of 2 bicuspids and 2 molars, we made 3 bicuspids and 1 molar. So we decreased the length of the cantilever. And instead of using these abutments, we used longer tie bases to prevent the fracture of the zirconia. So please think about it. We should be measuring bite forces before we start the patient. Look at this case. I think it's I thought it's a very nice case. This is one of my cases. Some pterygoids, some normal tilted implants in the anterior. Looks very nice. Beautiful soft tissues. Why? Because it's all zirconia. There's no metal in this prosthesis. It's an FP1, looks very nice. But there's one flaw here. The flaw is the long span pontics. Zirconia is a good material in compression. It is not a good material in tension. So when you have tensile forces on zirconia, for example, where you have long span pontic areas, long span bridge areas, these things have a tendency to break. And this broke after 1 year. Even though the connector size isn't bad, it broke here. So this should have been planned differently. The correct thing was to add an implant in the middle here. So you don't have this long span here. So I should have added an implant there. Or don't do it as a full contour zirconia. Do it as metal, like a titanium bar inside and zirconia. But then the prosthesis becomes bulky and the patient doesn't like it because the teeth are too thick. Anyway, the prosthodontist involved redid the case, the prosthesis, and here we have the redo case, and let's hope it's not going to fracture. Of note is the beauty of the beautiful soft tissues, the health of the soft tissues around the zirconia teeth. So this would be a good case to include Botox. Now that we measure the bite force, we found that the patient has excessive forces, Botox. And also remember, when we convert a patient to a full arch of implants, we lose a lot of the proprioception. So they may be biting harder than they would be biting if they had their natural teeth. And that brings me to the all-on-8 concept. This case, this previous case, is an all-on-6. Those are 6 implants. So maybe we should be adding more implants, like in this case, either do a sinus graft here and add an implant, or add a zygomatic implant on each side. And then your span will not be so long if you add 2 zygomatic implants like we did in this case. So my question now is, do you believe measuring bite force will change or influence your treatment plan?
Very good. Thank you, Dr. Costa. I will launch a poll for everyone to answer. I'm going to ask everybody attending here to select one of the three answers here. Please submit it. We'll give about a minute for everyone to submit, and then we'll discuss the results. So I believe, Dr. Costa, you should be seeing, like myself, the different percentages for each answer at this point.
I think you've put up question 2, or am I wrong?
Oh, I did, as a matter of fact. Apologies for that. I guess we'll do this one now as well. So I think we see fairly a much higher number, about 2/3 of the attendees are, yes, frustrated with prosthetic fractures and failures and implant components as well.
So what percent of the respondees have a problem with fractures?
So about 67% of the answers of the attendees are saying that, yes, they're frustrated with prosthetic fractures.
Okay, that's interesting. So I'm not alone.
And I'm surprised that about 29% are saying they're not really frustrated about prosthetic fractures, but they might have a trick that we're not aware of. Very good. So I'll end this first question. I think, Dr. Costa, if you're okay, we'll keep the second question for a little later in the presentation when your second question was initially.
Okay, let's go ahead.
Very good.
Thank you. So,
you might just have to close that little window, Dr. Costa, and then you can keep going with the presentation.
That's okay. So the bite forces will also obviously influence our treatment and materials of choice. Let's look at this zygoma case. It's a hybrid zygoma, which means we have some normal implants in the anterior region, and we have a zygomatic implant in each posterior area. The Zaga classification, according to Carlos Aparicio, is a Zaga 4 on the one side and a Zaga 3 on the other side, which means on the patient's right, we don't have any bone surrounding the implant at the crest, whereas on the patient's left, we have bone surrounding it completely crestally. This is the patient. Let's just go through the treatment of this patient quickly. There is a purulent discharge, previous failed implants. That's interesting. And he's got one implant hanging around there. Anyway, this patient has limited bone posteriorly, less bone posterior right than posterior left. That's why it's a Zaga 4 on the right, a Zaga 3 on the left. We're going to plan for 2 zygomatic implants there. And we're going to do a clearance. We want 12 teeth, top, 12 bottom. So 2 Zygos, 4 conventionals, and all on 6 on the bottom. We want to increase the vertical dimension.
Okay, open, close.
Okay, so we increase the vertical dimension. That's a Lucia jig for the desired vertical dimension, the wax up. And 18 months later, patient returns. This is the completed case. The implants are looking okay, fortunately. Sinuses are looking okay, but look at this. This part is loose. And the question is the prosthesis only loose, or are the implants loose? So in order to find out, we need to remove that loose prosthetic segment, and we need to torque the abutments and see if there's any mobility of the implant.
45 newtons.
Fortunately, no pain, no mobility.
And no pain, no mobility.
No pain, no mobility. So that's good.
It's
It's not the implant. So I'm very happy. I can send the patient to the restorative guy. It's not the implants. So the patient must now go to the restorative guy, and there's the fracture. And what is the solution? That solution in this case is to use photogrammetry to get a better and more accurate impression. The problem with photogrammetry is that up till recently, these devices were very expensive. For example, this device, which is an excellent device, the PIC device, photogrammetry, costs $45,000, whereas recently, the shining device, the 3D shining, has come down to $15,000. It's a Chinese device, and it's both an intraoral scanner and an intraoral photogrammetry, which means it's a two-in-one. It scans the soft tissues, scans the bite, and also does photogrammetry of the 3D position of the implants. So that's the photogrammetry, and then it merges the scans, the multiple scans, together with the photogrammetry. This is a publication. It's in press right now in the Journal of Prosthetic Dentistry, and they measured, if I remember correctly, 4 devices. They measured the PIC, the iMetric, another 2 devices, as well as the 3D shining. They found that the PIC was the most accurate, and so was the iMetric, very accurate. But the difference between these 5 devices, 6 devices was actually, no, 5 devices was actually clinically not significant. So the differences between these devices was not clinically significant. The big plus of the 3D shining is that it allows you to scan both and do photogrammetry and merge all the scans together. So with one device, you can do all the scans. Anyway, getting back to our case with the fracture, this is 3 years post-op, and you can see his soft tissues look remarkable, and he had new teeth placed at 3 years. But this time, because of his high bite forces, designed differently, there is a metal bar inside. These are zirconia teeth with a titanium metal bar to prevent another fracture, and we have a better impression with the photogrammetry. And this is the patient now. This is the 3 years post-op. We see our periapical X-ray shows a very good result. And there he is.
Yeah, how are you? You happy?
Very happy, no happy.
What he's saying
Very
there
happy.
is he's very happy. So I'm going to ask the question again. Or I'll tell you what, before can I show another case, and then we'll ask the attendees to answer the question. So can we just skip the question now? I'll repeat the question after another case. Is that okay?
Absolutely.
So neuromodulators. This is Simon O, also a very good friend of mine, and he says that measuring bite force with the Innobyte is a key factor, and it helps him determine if a neuromodulator, in other words, if something like Botox is necessary. So look at this patient here. Let's see the patient before Botox. What's the bite force? 1,200. 1,200 before Botox. That's high. That's very high. So 1 week after Botox, 900. So 1,200, 900. And 3 weeks later, look how much it's dropped down to 600. But it's important to be able to quantify these numbers. Otherwise, a patient says, well, is it really necessary? Well, why am I doing this? Do I have to do this? If we quantify the numbers and we show the patient, look, you started at 1,200, a week later you're 900, 3 weeks later you're 600, and then you can follow up those cases 3 months, 6 months later and repeat. Repeat the Botox when necessary. I wish I had done it to this case. This is my case. Have a look at this case. This is a severely atrophic maxilla. I placed 4 zygomatic implants. It's called a quad zygo. And I was quite proud of the result. I think I managed to get a reasonable AP spread. By the way, this is a case that had multiple failed implants before, failed sinus lift before, and was referred to me, and I thought I did a great job. But what I didn't do is I didn't measure bite forces. And this patient turned out to be a serious bruxer. So for 3 years, she would keep coming back to me with fractured prosthetic screws, fractured abutments, and I kept on sending her to the restorative prosthodontist. And eventually, she came back with quite mobile, what I thought were abutments, but it wasn't the abutments. Look at this. Look at this. I'm now supposedly removing the fractured abutment. And look here. Fractured implant. And another fractured implant. These are fractured zygomatic implants. In actual fact, 3 out of the 4 implants were fractured. And one may argue that these are narrow zygomatic implants. Well, this is a case. The previous case is this is my case. This is not my case, which was referred to me. This is a case that was treated in London with the widest zygomatic implants. These are very wide Nobel implants. And despite the fact being wide, these fractured. Look at this. This one fractured. It was actually the second one that fractured in this patient. So it's not only narrow, it's got to do with the patient's bite force. We need to measure these bite forces before this happens, or at least tell the patient before that this may happen. Then there's no need for us to make excuses, because when we explain something before, it's called an explanation. If we explain something after it happens, patient sees it as an excuse. So look at this case. This is my case. This is a disaster. We need to remove these implants. So there was one implant that wasn't fractured, and this was a wider implant. This was actually an oncology implant, which, as you can see from these numbers, it's almost 1 millimeter wider. And that's the only one that didn't fracture, but it did have some bending. And I decided to remove that implant as well, because I felt that with the bending, it was likely to fracture. I usually remove these implants if I can get a grip on them with these nice extraction forceps that have serrated, strong beaks, and the beaks close together. They don't leave a gap, so I can get a good grip on these. But unfortunately, I couldn't get that implant out with the extraction forceps. I couldn't get the implant out with the implant removal tool. This tool breaks at 320 Newton centimeter. It broke. So I had to resort to cutting this implant out with a Fisher burr. So I've got that out with a Fisher burr. Now I have to remove the stump here. Again, with a Fisher burr.
We would like to place ethos.
Now I'm grafting this. I grafted those 2 big holes. And now I'm going to the other side where I have to trephine the 2 stumps out. I have to use the appropriate size trephine. And here is the trephine with a roll extension. Now, it's loose, but I can't get it out. So I have to drill a slot in the stump with a Fisher burr. And then with a slot driver, I get it out. And now there's the last stump to remove. Again, with a trephine. This is very destructive surgery to get these implants out. Now I'm grafting it with allograft. And We need to remove lower implants as well, which are not integrated. You ask yourself a question. These broke, these aren't integrated. Why? Because the patient is a serious bruxer, high forces. I wish we had measured them before I started treatment. Look at this. These are tissue level implants. Remove them. Left two temporarily so she can have something to until come back. So the plan now is to wait for 6 months, which by the way is wrong. You have to wait 9 to 12 months. If you wait 6 months and you go back, the bone is still soft in the zygoma. We need to use wider implants. We need to use pterygoid implants if possible. You see, now we're treatment planning based on the patient's bite forces. We need to use osseodensification and, of course, measure bite forces and use Botox. Measure the bite forces. Use wider implants. You see, this is the southern Zygon. Use a Zygon W, which is significantly wider than the Zygon. Use pterygoids. You see how our bite force has influenced our treatment planning. And I want to share with you something we found over the years. We found that zygomatic implants bend. So if you consider these normal buildings here in Dubai as normal implants, they don't really move. But if you look at this tallest building in the world, this is the Burj Khalifa in Dubai, which is 800 and something meters tall. When there's a little bit of wind, this sways about a meter this way and about a meter that way. And if we look at these rods in a concrete foundation, they are well secured, let's say integrated in the concrete. You can't, but they do bend. If you kick them, they bend. And we can equate that to a Zaga 4, which means there's no bone circling implant. There's some bone on the palatal side of the implant to counteract occlusive forces. And if we apply a force there, it's like this force, the rod. And if we don't have those pterygoids, I've just removed the pterygoids from the panoramic X-ray, it's like biting on those zygomatic implants, they can bend. And when they bend, they can break. That's why we need to know if the patient has high forces so we can add those pterygoid implants, and we can also add Botox. We can use 20 to 30 units per site. So let's get back to this patient where I removed the implants. I waited 6 months, which I said I found was not enough. I placed 4 new zygomatics. I placed a Voma implant in the front. Unfortunately, I was not able to place pterygoid implants at the back. There was not enough bone. I should have rather waited 9 to 12 months. That's why we did not load this case immediately. 10 months post-zygo replacement, we see the zygomatic implants, we see the sinuses are clear, we see nice soft tissues around these implants. We're going to use Botox, masseters bilaterally. Next. Those are the areas we place the Botox. Go full depth into the muscle so that we avoid any branches of the facial nerve. You don't want the patient having a temporary facial paresis. And then we also go to the temporalis muscles bilaterally. Do the temporalis as well. And we can document our bite forces. We can document before and after a Botox. We can recall the patient, reassess the bite force, re-top up the Botox when and if necessary. Usually it's necessary. And we provide the patient with temporaries. These are PMMA temps. And then we provide the patient with the permanence, and we use the 3D scan, which is intraoral scan and photogrammetry, so we get the best possible fit of the prosthesis to prevent fractures. We are here, the prosthodontist is scanning the provisional, which he's happy with, so he can duplicate the provisional, and now he's scanning the bite. This is the bite registration. Now he's scanning the soft tissues. Now he's going to do photogrammetry, not intraoral scanning, photogrammetry of the implants, top and bottom. So photogrammetry is part of the game for better and more accurate impressions. And then the lower jaw, the soft tissues of the lower jaw, the implant position of the lower jaw, and then all these scans are merged together. The advantage of the 3D Shining, that's the one that costs $15,000, is that the system itself merges all the scans, not the lab, because when the lab merges the scans, you lose some accuracy. Scanning the various surfaces of the provisional, and then the lab, based on all those scans, makes the permanence. So in the case here is the permanent is made out of a acrylic covering, wrapping around a titanium bar, one piece, whereas in the lower it's two piece, because a full contoured zirconia lower, in the lower there's no metal bar, they will fracture due to flexing of the mandible. So we always do two piece in the mandible and usually one piece in the maxilla. So this is the maxillary prosthesis. It is very high-end acrylic. This is Ambarino from Italy, wrapping around a titanium metal bar, and that is screw retained to the 5 implants. And here is the case 1 year later. Periapical x-rays, the patient. So let's look at the bite force clinical applications. We said unitary restorations, one restoration. You can show the patient that because they're missing molars, they have a deficit. You can convince the patient to have a full coverage crown as opposed to a big restoration. In full arch cases, it helps us reduce failures by designing the case appropriately for excessive forces. It helps us decide that we want to use neuromodulators like Botox. And also for appliance therapy, bite plates, we can monitor the patient's bite forces as well as in TMJ disorders. This is a good study showing monitoring these patients with the Innobyte before and after bite splint therapy. So every patient, in my opinion, should have in the initial consultation a bite force measurement, as well as at the final prosthetic, as well as the follow-up. Why at the initial consultation? Because it will affect our treatment plan, and we can add things like pterygoid implants to prevent bending. If we're using zygomatics, we can add pterygoid to eliminate cantilevers, and of course at the final prosthetic and follow-up as well. And by measuring bite force with Innobyte, of course, and that's not the objective of the exercise, but we do generate more revenue. We have lower risks. We have happier patients because we've explained all these things beforehand to the patient. So it's a good practical innovation which allows for increased revenue. It gives us a competitive advantage because patients say, oh, nobody did that for me before. So this is a high-end practice. They're using digital technology. They They are more advanced. It gives us, the clinician, gives you, the clinician, increased credibility, better risk management, fracture prevention. It's improved quality of life for patients, and also, and very important, allows precise treatment follow-up. It takes guesswork, it eliminates the guesswork out of the equation. On that note, I'd like to thank you guys for listening to me. I would also like to thank my family, who are very supportive. That's my wife and our two daughters. The one daughter is a maxillofacial resident, a senior maxillofacial surgery resident here in Athens, and the other one is a senior radiology resident. And these are the two latest additions to our family. This is our granddaughter and this is our grandson. So thank you, everybody, for listening. And maybe, Fred, you want to ask the question now.
Yes.
About if people are still frustrated with fractures, or whether they would use something like Innobyte to do their treatment planning.
Absolutely. Well, first of all, Dr. Costa, thank you so much for this great presentation. I love the clinical cases and the fractures. We do have a few questions already. If you'd like to ask your question, please feel free to put it in Q&A or raise your hand. Before we do the poll, Dr. Costa, there's someone called Denise Duba that raised his hand twice during the presentation. So I'd like to allow him or her to ask the question live, if that's okay with you.
Yes, absolutely.
So Denise Duba, you can unmute yourself now, and please feel free to ask the question to Dr. Costa. The microphone, to unmute the microphone, it should be bottom left of your screen, and we can simply press it. Okay, while we figure this out, let's launch the last question, Dr. Costa, and we do have some more questions after. So everyone, we're going to be launching the last question. So the question is, like Dr. Costa said, do you believe measuring bite force will change or influence your treatment plan? So we'll let everybody answer. Well, Dr. Costa, it sounds like you did a very good job, because 87% of the attendees are saying yes.
Okay, so that's interesting, because both questions were quite similar, but it seems that more people are convinced that bite force is so important and we should be measuring it. The only reason we weren't measuring it up to now is because we didn't have the appropriate device to measure it. I mean, T-scan is a nice device, but it does not measure the force. It just tells us which tooth bites more than the other tooth. Am I right, Fred?
Exactly, that is correct. It measures relative point of contacts over the occlusion.
So this is a big innovation and a huge step forward, in my opinion, that we can now measure bite forces.
So let's look at the different questions we have. The first question is from Nabeem. Forgive me for my pronunciation here. Dear Costa, where do you draw a line or difference between bite force and inappropriate design in failing cases, knowing that we cannot do anything about bite forces other than over design?
Just repeat the question, please.
The question is, where do you draw a line between bite force and essentially bad design in failing cases, knowing that we cannot do anything about bite forces other than over design? I think Nadim would like to ask the question live. Let me allow him to do so. Nadim, yeah. Let me allow you to talk. Yes.
Okay. Hi, Costa. It's Nadim from Lebanon.
Hi, Nadim.
Thank you for this. Hi,
Thank you.
you?
Thank you for being
Nice
part
family.
of this. Yes.
Anyway, I distributed your presentation to all over the Middle East, so don't be surprised of the number that joined in.
Thank you.
The question is, where do you draw a line between a poor design and the bite force in causes of failing prosthesis?
Okay, so look, bad design by nature is part of the problem. But I think that if we add high bite forces to bad design, then we get bigger disasters. If we already have a bad design and we have bite forces and we don't want to change the design, then the only thing we can do is add a neuromodulator like botulism toxin. I'm not sure if I've answered your question.
Nadim, are you still there? I'm not sure if he's still there.
So basically,
yes, I'm still there. I'm still hearing.
So bad design is bad design. To start off with, we should change the bad design and make it a good design. But if we can't, for whatever reason, we should at least decrease the bite force. And to decrease the bite force, the only way that I know we can decrease it effectively is by neuromodulators like Botox. Of course, bite plates help, but
Yes.
if you have a bad design, that's bad to start off with, and then we add the bite force to it. We had that's really bad. So we have bad design and bad bite. So we have two bads. That's a disaster.
Just if I may add a little bit here to what Dr. Costa just said, like you mentioned, bite plates or night guards are helping reduce bite force, and we've seen this because we've done some tests with 3D printing different dentures and different vertical dimensions. We do recommend for any patient that is close to the excessive range of bite force, which is over 1,000 Newton, to just wear a night guard as a preventative measures. So it's kind of helping to reduce the potential risk of power functions down the line while helping to reduce the bite force. It's like Dr. Costa said, it's not reducing the bite force as much as Botox, like we saw, in the case, but it will help at least mitigate potential catastrophic failures.
If I may add, designing and over-designing in cases of where we suspect the biting forces are high should be over-designed and properly designed. No posterior cantilevers, no long spans in between implants. These are things that we have been discussing and it's been discussed all over the literature. I just want to attract your attention to Gunnar Carlson 40 years ago, when he published about bringing a patient from edentulous to dentated patient. Within 1 year, the biting force will go 10 folds. 10 folds. Can you imagine, just by putting a rigid implant prosthesis, supported prosthesis, the bite force can reach 10 folds when it is with the denture. So just to keep in mind that when we are properly rehabilitating our patients and giving them confidence and trust in their bite, the bite will go up, and it should have been considered in the early in the design. Thank you.
Thank you, Nadim. That's very interesting. This 10-fold increase. So if we have a patient who is in dentures, for example, and we measure his bite force, we should expect many fold increase. And that's an eye opener for the design, and we should be over designing. I agree 100%.
Thank you, Nadim. We do have more questions. Sheriff, would you like to ask your question live? Otherwise, I'll read it for you, Dr. Costa, for now. How long would the effect of Botox last, and how often would you inject it?
3 to 6 months on average.
So it's going to last 3 to 6 months, and when would you re-inject based on the bite force?
So I would measure before, like I showed in that video. I would measure before. I would measure 2 weeks later, because it needs a couple of weeks to take effect. And then I would measure again after 3 months, and if it's approaching the pre-injection level, I would definitely re-inject. So after 3 months, I would reassess. And if I see there's a significant change from after 2 weeks, I will go for it again. Sometimes it lasts longer. It can last sometimes up to 6 months.
Very good. Another question we have, Dr. Costa, thanks for the presentation. Again, the question is, how frequently do you repeat Botox injection? So I guess it depends on the reassessment of the force.
Exactly. And that's why we need something to be able to quantify it accurately. That's why we need something like the Innobyte. Otherwise, it's guesswork.
Another question now is, I am making my full arch design to be interior guided occlusion to reduce the bite forces. Would that work?
Yes, the restorative colleagues that work with me do exactly that. They do what we call a mutually protective occlusion. Of course, that's a big discussion on its own, but basically the front teeth must protect the back teeth in excursions. Mutually protective occlusion. I will quickly go through it. So in centric occlusion, the back teeth bite more than the front teeth, but in lateral and excursions and protrusion and anterior protrusion, the front teeth protect the back teeth. In other words, the back teeth disclude. And that's what seems to work best.
Very good. Anyone has any other questions? I think we still have a few more minutes. We can discuss those. In the meantime, I'm still trying to get the question from, oh, somebody raised their hand. I will let you speak right now. Thomas? Let's ask you to unmute. Please ask your question. You will need to unmute your microphone, Thomas, please. There we go. It seems that we cannot hear you. Perhaps if you don't mind writing your question in the chat or the Q&A, that way we can answer them. Do we have any more questions? Dennis Duba had a question as well. Can we get let me try to get the questions live. It seems that we're having technical difficulties getting the attendees to speak. Dr. Costa, I think, once again, a big thank you for the presentation. It was lots of great information. Everyone, thank you for attending the webinar. Feel free to reach out to myself or Dr. Costa if you have any questions or comment. Like I said, we will make the recording available if you missed portion of the webinar, and we will also provide everyone with a C certificate by email in the coming days. If you do have any questions, again, we have some more minutes. Otherwise, we'll say thank you to everyone. Thank you, Dr. Costa. I know it's quite late for some of you guys in Asia and in Australia. And we'll be happy to speak to you at a later point.
Thank you, Fred, and thank you to all the participants for taking time to join in.
Wonderful. One last question. How can we get training on using bite measuring device, and where can we buy it? So I'll take that question, Dr. Costa, if that's okay with you. The best way to do so is to contact me, and I can refer you to our partners and distributors across the world. We're distributed in several countries in all continents, so we'll be happy to make that introduction. In terms of the specific training, we do have what we call the Kube Innovation Academy, where you can watch many live courses on specific applications of ByteForce and the Innobyte, and we will be sure to be sending and sharing that link with everyone. It's all free. It's all available online whenever you want. So feel free to get some more training on it. And I'll be happy to discuss further with any one of you who would like to discuss specific questions on ByteForce or the Innobyte. Very well. Well, thank you, everyone. And once again, Dr. Costa, it's a true pleasure as always. Thank you for your time and helping out here.
Pleasure. Good night, everybody.
Good night. Bye-bye.